So I'm going to cover the right-hand rule the way I learned it in college. I started off as a math major and didn't switch over to physics until later. And so I learned the right-hand rule first in multivariable calculus. And so when I would do it, when I looked at my peers in physics who would do it, they were doing something like this. And I'm like, what are you doing? They're like, the right-hand rule. I'm like, that's not how you do it. It's how they did it, but I don't think that way is very good, because the reason why is they would label their fingers, and I don't know how to do it. They would label one finger B and Q and V, and then I would say, well, what if you're using F equals IL cross B? And then they were like, oh, well, then this finger's that. And they had to relabel their fingers depending on which right-hand rule, which cross product they were trying to do. And so my way is, if you know the formula, you have one right-hand rule. You don't label anything. You have to know the formula to start off with. So for example, if you want to know the force on a particle that's moving through a magnetic field, the formula is F equals QV cross B. And so you're going to remember that your whole hand goes with the first one. So that would be in V. You curl to the second, and your thumb is the answer. So you have to know the formula. F equals QV cross B. So right here I have a proton. And it's going to approach a uniform magnetic field that is vertically upward, and it is coming here from the right, and it's going to move to the left. All right, and what is going to be the force on that? And so it's moving this way, so my whole hand goes that way. And now I have to curl to B, and if it hurts, don't do it. You're doing it wrong if it hurts. So I'm not going to try to curl to B that way. I have to flip my hand 180 degrees so that it's easy to curl, and now my thumb is coming out of the page. And so that would be the answer for that one. Here, and the particle's going along, whole hand goes here. Can I actually curl my hand 180 degrees and have it fold on itself? No. If it hurts, don't do it. You're doing it wrong. Or in that case, no deflection. So when the particle is moving in the same direction as the magnetic field. Here's another reason why I like my version versus this version. This version, that people always hold their fingers at 90 degrees. But when you curl, it doesn't have to be a full 90 degrees. So now I'm going to have this time I'll have an electron. Now an electron is traveling to the right, and it experiences a magnetic field that is pointing to the right and up. And so the question is, what is the direction of the force on the electron? Okay, and so again, this was moving here, so my whole hand goes that way. I have to curl, so again, I'm going to curl. It's more comfortable if I flip my hand 180 degrees so I can curl. And my thumb's coming out of the page, but I have to remember that the right-hand rule is always for, if you're doing it for particles, it's always for positive particles, and so that was an electron, so that would be into the page. So you just flip the vector 180 degrees when it's an electron. And so that's what I like about my way, is because I don't have to curl full 90 degrees. I can, as long as I curl some amount, then I get the correct answer. And if you don't curl at all, of course, the answer is no deflection. Let's proton now traveling to the right and experiences a magnetic field. And you can see that it is into the page, because that's what those X's mean. And so now I'm going to go QV, and now to curl to into the page, I have to flip my hand like this. I curl into the page, and so the proton's going to go straight up. Okay. Oh, I thought I had dots on the other side. That would have been smart, but I didn't. All right. So again, the reason why I like mine better is because if the formula switches. So now you put a wire in a magnetic field. And so now, you have a current carrying wire that's going this way. And now I go, oh, the formula now is F equals IL cross B. I don't relabel anything. I just go, IL is the direction of current, is how you put your whole hand, cross B, and then the wire will go up in this magnetic field. If I'm trying to use Biot-Savart, So if I have current carrying wire right here, and then I ask you, what's the magnetic field right here? Bios of R says it's IDS cross R hat, okay? And so I would be this way, and I have to curl to R hat. So R was, I said it was here, so to curl to R, I have to go there. And so that means that at that point, it is going to be into the page. Now, would I use Bios of R to figure out B for current carrying wire? No, I'm going to use the right-hand corkscrew rule, which just says grab the wire, bam, current was going that way, and so my fingers are curling this way, and so it would be at that point right there, it would be into the plane if we had an imaginary plane that this wire was in. If I had to know the right-hand rule, if I was figuring out torque, or if I was figuring out angular momentum, my rule, I don't have to relabel my fingers. It's always hand, curl, thumb is answer. All right, here's our last example. I have current carrying loop right here. Don't ask me how the current gets in there. It just somehow magically does. And it's a loop of wire, and so it's going to spin. There's going to be torque on it. And so we can figure out, first of all, the fact that it is going to spin using the right-hand rule. So I'm going to go, let's say I'm going to do the top first. I go IL cross B, and so that's out at you, coming out at you, out of the page. On this side, my hand would go down, and to flip 180 degrees, I go, oh, no deflection on that wire. On this wire, now I have to have my hand going this way, and to curl up, and now my thumb is into the page. So it was out of the page here, into the page here, and here there's going to be no deflection, and so this will spin. And so again, we said it was out of the page here, so it's going to spin, it's going to come towards you.